Welcome to HCD's Mindset. I'm Michelle Nigella.
And I'm Kathryn Ambrose.
We are on a mission to help you identify what consumer science innovations have a lot of untapped value or are too good to be true.
So join us for more curious conversations as we try to make sense of the complex but fascinating world of human behavior. Hello, everybody, and welcome back to Mindset. We are so happy to have you here today, and we're really excited for the guest that we have on. We've known each other now for a bit of time, but it was about time that we had you join the podcast, Tian. Today we have Tian Yu, and I would love to hear a little bit about who you are and how do we actually know each other? Because we have been friends for a good amount of time now.
Right. Thank you for having me here on your podcast. A little bit of who I am. I am right now the director of sensory at a technology consulting company, Aigora. Before that, I had my PhD in taste neuroscience. First about the fat taste and then about sour taste. Then at the time, I also interested in system biology a little bit. So I trained myself about data science. And during the pandemic, I have the way of the new way of networking. That's how I got to know John Ennis. And I started on this field that combined data science and sensory consumer science, which I had some experience before. So this is where I got to where I am right now. So I think, Michelle, I know Michelle longer because we have very similar backgrounds.
Mm-hmm.
We all coming from the taste field. So Kathryn, we know each other from the conference. So happy both.
And I think I met John first from Aigora. And he introduced me to you. However, we've been in the same circles for quite some time now. If we harken back to our academic neuroscience world, you've worked with Thomas Finger, is that correct?
Yep.
Yeah, so we used to receive mice in my grad lab from Tom Finger's lab. So they were the neurotrophin knockout mice, I believe. So
it all goes back to mice.
At some point it all goes back to mice. And so thinking about your background, what animal model did you work in?
So in graduate school, I worked with both rat and mice. So in postdoc, it's mostly mice, and also, of course, work with various cell lines. Yeah.
Very cool.
So why? So you decided to go to grad school to get a PhD in, taste neuroscience and genetics, which is really specific. I mean, when I talk to people about coming from, behavioral neurogenetics, it is very specific. How did you get there? Did you always want to be a taste neuroscientist, geneticist, or how did you become interested?
Right. So story is I actually have a very big interest in a more general form of neuroscience. I'm just amazed, fascinated by how brain works. I love reading all the science books around, explaining how, brain works, and medical field in that perspective as well. So in graduate school, I was just applying for neuroscience. The taste neuroscience was a little bit of accident. I didn't really plan to go to that field, but I really love it when I got to that lab. So I stayed.
So you did one of those rotations. And whose lab were you working in?
So at the time was Tim Gilbertson's lab. So we're looking at the fatty taste. So we have 5 general tastes, and our lab always promote that there's a 6th taste, which is fat, more like texture, fat, related. But how do we define that in a neurobiological way? The taste transduction pathway, receptors related to it. So that's where we were looking at the time. Yeah.
Really neat. Yeah.
Yeah. And so can you take us a little bit, and how does this, like what you did in the lab, how did that, you go from there into the space that you're in now? Because you do still do a good amount of work in sensory science and,
It's not the
combining it.
same, right? I mean, you're talking large data, you're talking very advanced technologies, which while those are used in taste neurogenetics, what brought you to become, with Aigora and with data, and et cetera?
Right. That's a very good question. So yeah. So I think the education in some ways is kind of broader your views of things. So I take my, the graduate school and the postdoc training. It's more of to open your eyes to see what is possible. So including, accepting new technologies and not just focus on what you've been always doing, Western blot or, PCRs or all of those things. At the time, while I was in graduate school, actually, I was always thinking if there could be a way more systematically approach biological problems. That's where I got to my first postdoc is a system biology lab. Actually, they kind of combined the cell line work and image analysis work together in trying to kind of find trends and patterns in the cell, let's say cancer cell propagation. So that's where I got interested in, is there a way to more systematically approach biological problems? So throughout the years, I kind of trying to include those ideas in mind. So I try to learn a little bit more of data science, like coding, in a biologist's way, not like hardcore way, but like, biologist's way. But then as I said, during the pandemic, it's kind of like eye-opening. I don't know. It's a good experience for me, this whole COVID thing. I had the way to interact with new people that I never had chance to. So that brought me the opportunity to have conversations with John, and I just volunteered to work for him, and then that brought me to where I am today.
So what I find interesting is you were kind of describing yourself, before COVID as being a biologist. So how would you describe yourself now?
I still have biologist nature in me, but I would be more of, well, part of it is a consultant, part of it is data scientist, computational sensory scientist. And I'm a little hesitant to say that word, but I really want to be like more of like a future. I see people using that label on themselves.
That's a topic in of itself. And I feel your hesitation, because people do throw around the title futurist, and it's like, well, what does that mean? And you hear people that'll say, they have a master's in futurism or something of that sort. And it sounds kind of hokey, but I think what you mean, and I think what they mean too, is that you're forward thinking on technology, right?
Exactly. It's that forward thinking is like not exclude things, but try to see what is possible going into the future.
That makes sense. And I think that Aigora is, they do that. Like you have the space to kind of explore new technologies and really get a little bit of time to feel things out and be at the forefront of what is breaking and what is cutting edge. And I think that's a bit of what we wanted to talk about today, is to really break down, because Michelle and I have been seeing a lot of misconceptions too about buzzwords. Like we were just talking, futurist is almost becoming a little bit of a buzzword, but more so than that, one of the more original buzzwords is AI, where I think data science is like, data science is like the stepsister, like the ugly stepsister to AI, because you're doing the exact same thing. It's still data science. But
AI sounds a lot more fancy. And, you're bringing up being at the conferences together. And I think that's where we are really seeing that misconception fully on display. where you're having people talk about AI when what perhaps they really mean is machine learning, or in some cases, all they really mean is regression analysis, and it's not really AI. And so we were talking with you about these technologies and what makes something smart, right? So can you maybe describe, because I've seen you do this in talks at conferences where you kind of break down what this area is with AI and machine learning and sort of the different aspects. How do you distinguish these, and how do you feel about the sort of misunderstanding people are having?
Yeah, I would almost start with like a definition of AI. Like, let's start at the bottom.
Well, so AI, I feel like these days people talking about AI, they're based on a different level of knowledge, pretty much. So when I was talking in a conference, I was having an audience of sensory and consumer science, and this AI in this area is actually pretty concrete. Like, you have the data that you have about products, either is, consumer survey or sensory profiling data. You have those data in your hand, and then we can use machine learning models to help predict some of this consumer perception metrics, whether it's a liking or something else, right? So that is a very concrete example of how to use AI in sensory consumer science. On the other hand, when people using this word AI, they probably refer to a lot more stuff that they have received from media and everywhere else, right? And I have to say, in some of these areas, the use of AI is much, much more advanced than the sensory consumer side. There's a reason for that, and we will come back to this point later. But let's say, like, lately, very recently, there's this Chat GPT stuff, which everybody is trying. It seems so smart. It may not give the most correct answer,
Right.
but it's a very good answer from a machine.
Yeah.
Right. So it seems like very, very smart. And this is one example. Like, before that, we have, like, even in 90s, we have this Deep Blue. I don't know if you remember, it's on the chess game.
Yes.
And it beat the world champion at the time. Just was, I forgot his name, but so beat a world champion. And there is AlphaGo, which the Go game, right? It beat the world champion. That's more lately, like in 2020, I say, about like that, or a little bit before that, before pandemic for sure. But then there's AlphaFold, right? I can predict the protein structure. All of those seem so smart, but if you look at it, the logic, they all based on a comparatively simple logic, but they had very complex variations, and they had tons of data to build these models. So these are where artificial intelligence, machine learning models can really thrive. This is how I look at that. Those are great examples to prove how, like, a group of very smart programmers and using their intelligence to tell this machine to do, and they based on lots of hours of learning, lots of materials to learn from, and then they can come up with a little predictive model that can behave or much better, much better than a human being can, with a human brain can do. So this, I think, this is where the smartness of AI is coming from, but the behind the scene is that they have been trained with a great amount of data, and the logic is comparatively simple and clear in this context.
So you think that the thing that's making the data smart is really just it's the diverse amount of sample that it can pull from to actually produce and, like, give an output that is impressive to us, like to the layperson.
Right. So here is the thing. If I want to explain what AI is, I think AI to very simple, maybe not the exclusive explanation, is that AI is really good at finding patterns. So what it is doing is just trying to find patterns, relationships of those data. So depends on what your data is, the AI finds the patterns within that boundary of that data.
So one thing that I kind of picked up on you talking about was, again, that sort of brilliance, right, between the AI and the human brain. So I think a question that people then end up having when they see something like ChatGPT come along and they've seen all the, post-apocalyptic horror movies, sci-fi movies, of this idea of like sentient computers that, do whatever they want. But the way I've always talked about the brain is that it is so amazing, right? Because of the number of connections. So I think a question people have a lot is whether or not computers can really be like the human brain.
Well, yeah. So I've heard people saying this thing. They say the technology is only as good as its programmer.
Right.
Right. So at least from what we are right now, I don't think human brain is ever even getting close, not even that, to getting close to replace at all. There's really just human brain trying to tell a machine to do what it's really good at.
Do a job.
Yes, exactly. But the actual job, the concept, the conscious, the cognition, all of those are still coming from a human brain. It's not coming from the machine itself. Of course, it can come into, the physiological part of the question if it will get smart enough to get self-awareness or machine, something like that. Personally, I think is at this moment, I don't worry about that, at least. Yeah,
I
but
agree.
going into the future.
Yeah, it's interesting because I think that also brings up and it raises the point that there's this misconception that people often think that AI means that it removes human error because it is just everyone thinks of it as code. But I think you bring up a really good point here by saying it's only as good as the programmer, because when there's AI, there is still human involved somehow. Like there is a way, if you trace it back, it goes back to somebody that's sitting behind, and coding their code. So what are your thoughts though on the idea, if somebody was to come to you and say, oh, is AI really removing human error? Is there ever a situation you think where we'll actually be completely free of human error?
I actually don't think so. AI will make its own errors if we're not careful enough. There are errors everywhere. And it being able to remove is only to the part that, the human is telling. It's trained.
Like what should they remove?
Yeah,
right.
Exactly.
Because I think, the other side of AI, when you're talking about, kind of quotable things about how to describe AI is that bad data in is bad data out, right? So when it's collecting all this massive amounts of data, it's collecting the good and the bad, right? So it's collecting all the mistakes as well, which is where we end up coming with, racist facial recognition, right? Or, really racist tweets coming from an AI generator, all those sorts of things.
Right, exactly. So it's, from collecting data point of view, there's probably no right or wrong from collecting data, but from building the model point of view, you want to be really representative of what you want the question is answer, right? If we're doing this emotion AI or, want to use this technology to predict in this area, you probably want to include a wider data set. You want to wherever you want to use this model to, you want it to capture all of the possible scenarios that it could ever seen.
Yeah. And that's really interesting because you're talking about sensory science being very concrete, because you have your panel data, the sensory attributes, and you have the consumer data, and maybe you have the the product data, the rheology or whatever it might be of the actual formulation. And that is really concrete. There's not a lot of mistakes, like not a lot of bad data really, right? But then when you think about something that's maybe little more gray, a little dirtier, like emotion, where we're not even sure about the science of emotion, right? So then it's messier. So how does AI deal with that?
Well, so from AI point of view, there are definitely part which I don't think people will have a clear answer to that, like sarcasm. It's just very hard to pick that up, right? But if you're working on a smaller, more concrete, question, we always start from the more concrete questions and maybe move up to more complex questions. You do want to, let's say, if you want to detect something, I don't know, like say angry, but then the angry expression can be different across the demographics from different cultures, different people from different countries. But then if you want to detect angriness and you want to use this model in a wider demographic population, then you do want to include all of those data points for this angry model to learn from. Then you are actually pretty sure, you're very confident that this model can answer if you are detecting, or even say it's not even assigned it to an emotion. Maybe it's not angry. What you are predicting is this person is, like, say, higher pitch of voice, or you raise eyebrow. It's more concrete detection than that. So how do you assign that to different emotions? That could be another, cultural related problem. So when you're like discussing the AI topic, we're not discussing something like broad, like Chat GPT kind of smartness in the first shot. The first step is always just find those patterns from the data that you have. So even Chat GPT is starting from finding patterns of your answers, your text from the web text answers and questions. So that's the same thing that we're doing as well. You start with some data set. It can be representative of what you want to have, right? The answer is based on what question you're asking. But then we slowly roll the ball up and see if it can fit into a more wider scenario and if it's predictable or not.
Yeah, I mean, that makes a lot of sense, because you want to make sure that it fits within the context that it's predicting too. Like you always have to have that nuance of the context involved. But as you were speaking, it was honestly, and giving that example of anger of if people were angry, I was even thinking for things that are a bit more concrete, like liking, I was like, well, it brought me to, even if they have something like a Likert scale and it seems pretty concrete because it's closed and there's not a lot of room for interpretation, you still have the limitations of like the basic things about, does the consumer actually, or the person participating, actually understand what they mean by liking when you're saying a 5 versus a 6 on a scale. So it's not like the AI is magically going to be able to interpret that and say, oh, this means that they actually really, really like this. It's just like you've been reiterating, picking up on the trends and the patterns that are already established based on the data provided.
Exactly. So when you're talking about consumer liking, if we use that column, consumer liking, this is what the model will predict. Whether this prediction, this score really represent what consumer would think, that is totally it's a different question.
Absolutely. And I think that that's important to make note of too, as people are becoming more familiar with it, because the truth is AI is being more integrated with the ideas of Chat GPT. And, I've been seeing Lens AI as well. People are paying to have, portraits of themselves. So the idea of AI is really exciting people, but I like these nuances. And I also think the limitations of AI can't be.
With great power comes great responsibility too. There's been a lot of argument around the like copyright, right? So when we think about, where the image generating AI is like scouring the internet and collecting art and then, making art from people's self-portraits and, so making you a Renaissance person or turning me into something very Da Vinci-esque, right? Is that in fact copyright infringement? Are you stealing from artists?
Yeah. Yeah, there's I think a lot that still needs to, and this is the case with technology in general, that I think technology always will be faster than legislation and faster than, like policy, because that's just the nature of.
Not sure that legislation has really even grappled with any ideas of the internet, much less
right. Exactly. So it's one of those things. It's like almost like a wait and see. And to Michelle's point, with great power comes great responsibility. Spider-Man's quote, it's up to us to really be sure, while there's no regulation on it, that we try to spread the word about what these limitations are, and not to just take everything with a grain of salt.
But there is really good usage as well, right, Tian? So the work that you're doing in sensory sciences and consumer research, can you kind of, with it, you obviously you don't have to tell us any of like the specific research questions that you deal with clients, but in general, where have you seen applying artificial intelligence to this sort of data? What sort of research questions have been most useful?
Yeah, definitely. So in our field, as you would also know, we do, the CPG companies likes to do the consumer survey to understand the market, how their products is doing there, and if they want to roll out a new product, how it would be fit in the market, and would they be liked by the consumers, all those questions, right? So the consumer surveys are expensive. They cost lots of money. Right. So there's a big drive in this field that, let's say, before we actually go into, the actual consumer survey, is there like machine learning can help to see if this product can fit into the market first. We're not saying, say, get rid of the consumer survey altogether, but if we are developing, say, 10 prototypes, right? Which one will have the higher probability to behave better in the market. We don't really know that. But from the data that we've seen about this specific category, the previous historical data about consumer, like say, evaluating different flavors and something like that, we can have a good prediction of what this new prototype will fit. Would they like it or no? So these are based on the historical data that we already know from this company, and then the market as well. So this connection of the production of this product and the market, this connection by machine learning models, or AI, you call it, it's been very helpful, and it helps with the product develop cycle so much better, so much faster. Yeah.
That's awesome.
Yeah,
I'm sorry.
That's a classical user case about machine learning in this area. But also, when your data is ready, you can also predict like sales trends, things like that. But it's all based on whether you have the right data to help answer this question. Yeah,
that makes a lot of sense. It all comes back to really the quality of the data, the diversity of the sample. I think that is, it's always going to be the foundation of your research. It's really what the legs stand on. But I want to make sure that we have time to go into our game that we're going to be closing out with.
Before we get to that game, I do want to ask one more thing, which is,
please
put your futurist hat on. We're going to embrace the role of futurism. What is it that you would maybe it's a good question is, what would you like to see as the next step for AI? Maybe specifically, let's keep it specifically to sensory and consumer research. Like what do you think is the next step, or something you'd like to see?
So that I would really want to see like AI being used in not just from predicting the consumer liking from sensory data, product data, but it applied to a wider areas of this sensory consumer or marketing area. So that will require this whole field or area is moving towards more like digitization. You have more data ready. So as the CPG companies, they have more of data ready to be able to apply AI on. And then the field, let's say, either us or some other companies can come in, grab those data and try to predict on every single step that they can think of. So if this step can help the field moving faster, product develop faster, or understand consumer better, whatever the trends, sales, market, everything, if you have the right data, you can do it. So that's what I really want to see. It's not just being on this product development, the little cycle that we defined, but on the broader area.
Yeah, I'd like to see that too.
Same. I agree. Fingers crossed. We'll see what happens. Awesome. All right. So I know I warned you a little bit before we started the recording, but just a reminder, game is called React Attack, and I'm just going to be listing off 10 random words, and you're just going to share the first thing that comes into your mind. It's a rapid fire free association exercise. So are you ready? I have the 10 words prepped and ready to go.
Yeah, I'm very nervous. Yes.
Oh, nothing to be nervous about. All right. So the first word is robots.
And
so you used to say that
I have to just say
First word that comes to your mind.
Okay.
Yeah.
Robots. I would say machine learning.
Okay.
Yeah.
That's funny. Machine learning.
Yeah, I think robots can be
That's fair
as well, right? It will be a very smart robot. Yeah.
Predictions.
Consumer.
Smart
Yeah.
speakers.
Answers.
Overgeneralizing.
Risk.
Diversity.
Diversity. Oh my God. I would say broad.
That's good. Privacy.
Myself.
Internet.
Information.
Interpretation.
Intelligence.
And the last one, taste.
Taste. Yummy.
Love it.
Awesome. Well, thank you so much for joining us and helping us dive into a world that Michelle and I, we're not experts in, so we'd love to have the experts on with us. And we really appreciate you kind of helping to not just dispel myths, but explain some of the limitations and get a better grounding of this world of AI. So we just want to thank you for joining us. Is there any way that people could connect with you if they have any questions or want to reach out?
Right. LinkedIn would be the best place to reach me. Yeah.
Awesome. All right. So we'll be sure to have Tian's LinkedIn in the bio and we'll have her LinkedIn in the show notes. But other than that, we just want to thank everybody for tuning in. And until next time, take care.
Thank you.
Thank you.
For more information or updates, follow HCD Research on LinkedIn, Facebook, and Twitter at HCD Research Inc. and at HCD Neuroscience. Subscribe to our YouTube channel and be sure to rate, review, and follow us on Apple, Spotify, or wherever you listen to podcasts. Thank you and stay tuned for more curious conversations.